We're going to take a look at another function operation. It's called function composition. So we've had function addition, subtraction, multiplication, and division. So the last one we need to look at is called function composition. And kind of a definition is if x is in the domain of g. So remember the domain for us was we couldn't divide by 0 and we couldn't have a negative in the square root because we wanted to keep things real for these real functions. If x is in the domain of g and g of x is in the domain of f, then I'll refer to it as fog fairly often, but this is f composed with g. The little circle there, that means composition, so it doesn't mean multiplication. F composed with g of x is equal to f of g of x. So how this is going to work is you're going to find what g of x is, and you're going to get either an equation, or you'll get an expression, or you'll get a number, and then you're going to take that and plug it into the function f. So we'll do a little mapping picture down here. So we're going to start in the domain of g, and then g is going to take this number x, and it's going to map it to its output of g of x. And then the range of g is going to fit into the domain of f. So the range of g would kind of be this little circle here. It's going to fit within the domain of f. We have to make some restrictions because we don't want to go outside of the domain of f. So if we had something that came out here, that's not in the domain of f, so that wouldn't be a valid input. So we would throw that out in order for the composition to work. Okay, and then the function f is going to go ahead and take g of x, which is just a number and expression, and it's going to map it to f of g of x. So, give you an example. We start off at -1, g does some stuff to -1, so you input -1, g gives you an output of -2. And now we're going to take -2 as our input for f. When we input -2 into f, we're going to get an output of 9, for instance. So this is what composition's doing. So you're feeding a number in to one function, and it gives you an output, and then you feed that number into another function, and it gives you a new output. And you can do this with as many functions as you want, but I think we'll probably stick with just composition of 2 functions. Alright? And how I read this is f of g of x. So I can read this as f of g of x, or f composed with g of x. So one thing you got to be careful is it's kind of backwards. Usually we do left to right, but the way this is understood is g of x is the inner piece, so that's what's going to happen first. Okay, so we'll do an example. So I'm going to give you 2 functions. I'm going to give you a polynomial and a linear. And then I'm going to ask you to find f composed with g of -1. Okay. And so what we're going to do is we're going to plug -1 into the g function, and that's going to give us an answer. It's going to give us a number. And then we're going to take that answer and we're going to plug it into f, and we're going to get a new answer. Okay. So f of g of -1. So the g function takes input, multiplies it by 4, and then adds 2. Okay. So what are we feeding it? So multiplies by 4 times our input, and then adds 2. So we're feeding it a -1. And we'll get -2 as the answer inside the parentheses there. Now we're going to feed -2 into the f function. The f function takes input, it squares it, subtracts 2 times its input, and then it adds 1. So we're feeding it a -2, so we're going to square the -2, then we're going to subtract 2 times the -2, and then we're going to add 1. So just evaluating the function at this point in time. And we get an output of 9. So that was actually drawn on the previous page. -1 got mapped to -2, which in turn got mapped to +9. And that's just what the function composition does. We can compose a function with itself if you like. So we're going to do that here. F composed with f of +1, which means f composed with f of 1. Okay. So to find f of 1, we're just going to plug in 1 in for the x, and we're going to work it out. Okay, so replace the x's with 1's, and we're going to get an answer of 0, because 1 squared is 1, and then we have a 1 right here, so there's 2, and then negative 2 times 1 is negative 2, so this all sums up to 0. And now I'm just going to, it says to take the function f evaluated at its input, which happens to be 0, so we're going to plug 0 in. And we get an answer of 1. Okay. We'll do one more. We can do either order. Now we're going to do g composed with f of, I believe, negative 1. Or maybe we'll do positive 1. Okay. Alright, so g composed with f of 1. We're going to plug 1 into the f function first. So this tells us to do the f function first. We're going to plug 1 in, and we actually did that right here. I already evaluated the function at 1, so we should get it. F of 1 is going to be 0, but we can go ahead and go through the steps again. And g of 0. So the g function takes input, multiplies it by 4, and then adds 2. And there you have it. We could have also done g of f of negative 1, and we probably would have gotten an answer that's not the same as 9. So addition and multiplication are commutative operations, which means we can do them in either order. We can switch the order. Subtraction, division, and composition are not commutative, which means the order is important in how we do things. And if we switch the order, the composition will give us a different result. Okay, so one type of problem is they'll just have us evaluate composition of function at numbers. They'll also have us look at a graph, and that's what we're going to do on the next page, is a graph. And then they'll end up asking us to just find the formula for a composition of functions, and then they'll want to know what's the domain of this composition. Okay, so we'll go ahead and draw in the graph here. So we're just given this graph, and we're going to be asked a couple of questions about it. Now, if you need to pause the video to draw the graph, you can. And I'm going to ask you to find compositions of two things. So I'm going to ask you to find the fog, or f composed with g of 2. Okay. But in order to do that, I need to tell you which graph is which. So this kind of curvy looking thing above is g, and then this f kind of looks like an absolute value function maybe. We're going to ask you to find what f composed with g of 2 is. So that's what is f of g of 2. So we're going to work inward, the inside first. So we're going to find what g of 2 is. So the inputs are x. So we're going to find where 2 is, and then we're going to find g of 2. So g of 2, here's 2, and then the output of g of 2 is 3. Okay. So this time we don't have a formula, we have a graph to tell us what g of 2 is. So we're going to replace g of 2 with 3, so now I'm going to ask you what is f of 3. Okay. So now we go down to the bottom function, and we're looking at 3, and I want to know what's the output. The output appears to be negative 1. So when we plug in 3, our output is going to be negative 1. Okay. We'll do one more. Let's do g composed with f of negative 1. So that means g of f of negative 1. So we'll start with the innermost piece, which is the negative 1. F of negative 1. So f is the kind of v-looking thing, and we're going to look at negative 1, which is right here. The output appears to be positive 1. Okay, f of negative 1 is positive 1. Okay, so that's what we're going to replace f of negative 1 is just positive 1. Okay, and now we're looking at the g function. The g function evaluated at 1 looks like it has an output of 5. Okay. Alright, so you just need to be careful, know the definition. You're going to be working on the innermost piece first. and then you're just finding x and y coordinates on a graph. All right. The last one is probably the biggest concept out of here is finding kind of the formula for a composition of functions, and then finding the domain. And the domain means we can't divide by 0 and we can't have negatives under the square root. All right, so finding the equation and domain of a composition. And we're going to do both ways. So f of x, we're going to say, is the square root of x, and g of x is equal to 5x plus 3. Okay, so we just picked two functions, and I'm going to find both the fog and the goff. So I'm going to find f composed with g of x, and g composed with f of x. Okay, f of x has a square root, so that's going to pose possibly a problem here. So we need to ensure that it's positive by taking the radicand and setting it greater than or equal to 0. So our domain is going to be, we have to be 0 to infinity, including 0. The g of x is everything. And unless we have a square root or a denominator with a variable, the domain default is everything. So we're going to do both compositions. We're going to find f composed with g of x. All right. Now g of x is this 5x plus 3, so that's what we're going to replace the g of x with. It's 5x plus 3. And our function f takes input whatever we feed it, and it takes the square root. So here we're feeding it 5x plus 3. Okay, and there's your composition right here. That's your formula. Now they want us to find the domain. So g of x as itself didn't have any problems. However, when I feed things from g of x, I might get some negatives. So we're going to have to make a restriction on this. So I'm going to mention again that the radicand has to be greater than or equal to 0. So the radicand is the 5x plus 3. So 5x plus 3 greater than or equal to 0. Then subtract 3 from both sides, and then divide by 5. And x has to be greater than or equal to negative 3/5. So our domain of this composition is going to be negative 3/5, including the negative 3/5 to infinity. Okay. So that's the fog, and the only new thing is coming up with the formula for the composition. Finding the domain is the same thing as before. Okay, now we're going to find the goff, or the g composed with f of x. So that means g of f of x. Okay, so f of x is the square root of x. Okay, and our function g takes input, multiplies it by 5, and then adds 3 to it. So here we're feeding the g function f of x, and f of x is the square root of x. Okay, so then that gives me 5 square root of x plus 3. That's my formula. Oops. Let's try again. That's my formula. And we have a square root there, so the radicand has to be greater than or equal to 0. X is greater than or equal to 0, and that's the domain of g composed with f of x. It's 0 to infinity. Also, we started with the f function, so the f function's domain is 0 to infinity, including 0. So we couldn't get any negatives to start off with because we started with f. That's our starting place. F's domain is 0 to infinity, so we couldn't get any negatives anyways, but you can find the domain afterwards. Okay, so I have two more. A problem like this I like to put on the test. So we're going to look at the reciprocal function, and then we're going to look at a shift of the reciprocal function shifted left 5 units. Okay, so both of these have denominators, so the x can't be 0, so we get the negative infinity to 0, union 0 to infinity, and then the x plus 5 can't be 0, so x can't equal negative 5, so we get the negative infinity to negative 5, union negative 5 to infinity. we're going to go ahead and find the hog, which would be h composed of g of x. Okay, g of x is that 1 over x plus 5. And what h of x does is it takes the reciprocal, or you can just put the whatever you're feeding it in the denominator. So we're feeding in x plus 5. Okay. Now we originally started with going from g, and g had the restriction that x can't be negative 5. So we're going to mention that here just to remind ourselves. Okay. Now we gotta make sure that we do this, because if we don't, then we may get the wrong answer for the domain. Now, this is h is the reciprocal function, so if I take the reciprocal of 1 over x plus 5, that's just going to flip it over and make it x plus 5. Now, if we just look at that, you would say, oh, the domain's all real numbers, but we got to remember where it came from. It originally came from g's domain, which meant we couldn't be negative 5. So if we're going to start with g, we can't plug negative 5 in originally. Okay, so we got to be careful there. All right, now if we go the other direction, the I guess you can say, g of h of x. H of x is the reciprocal function. G is going to take your input, add 1 to it, and then take the reciprocal. I'm sorry, it's going to add 5. So it adds 5 to its input and then takes it the reciprocal. Now we're coming from h's domain, and h couldn't be 0. So we're going to make that mention right here. X can't be 0. And this one's a little bit trickier. I have to go ahead and multiply by the LCD, or LCM, which is x. So we're going to fraction bust. It's x over 1 plus 5x. And we still have a denominator here, so I got to make sure that's not 0. So we're going to set the denominator not equal to 0. Okay. So how I came up with that is I subtracted 1 from both sides, and then I divided by 5. So your domain is going to be everything except for 0 and negative 1/5. Okay, so negative infinity to negative 1/5, negative 1/5 to 0, and then 0 to negative infinity. And to help with the domain, you can always draw yourself a number line, and we'd put negative 1/5 in. We'd put 0, infinity, and negative infinity, and that can help you with the interval notation there. Okay, one more example. So I get something a little bit more complicated, not too bad though. So I mentioned the domain of this one and another g of x. And we're going to go ahead and find fog and gof. Okay, so if we find f of g of x, g of x is the x minus 1 over x minus 3. So we're going to replace those x's with x minus 1 over x minus 3. So your function takes input, adds 1, or it doesn't add 1, it adds 8 in the numerator and adds 7 in the denominator, and your inputs are going to go here and here. So we're feeding it x minus 1 over x minus 3. Now I came from the g function first, and g's domain had the restriction that x couldn't be 3. Now this is what's called a complex fraction. You have a fraction in either the numerator or the denominator or both. We have fraction in the numerator and the denominator, so we don't like that. So we're going to multiply by the LCD, which is x minus 3. Or rewrite. And multiply by x minus 3 over x minus 3. So using the distributive property. So I'll draw the arrows in real quick. So x minus 3 times this first piece, that gives me the x minus 1. X minus 3 times the 8 gives me the 8x minus 3. And then we do the same deal in the denominator. Now I'm going to go ahead and simplify this, so I'm going to distribute the 8 and combine like terms. Alright, and then we got one more little thing we got to do. I got a denominator with a variable, so we got to set that not equal to 0. And if we add 22 and then divide by 8 and then reduce, cannot be 11/4. Okay, 11/4 is 3.75, I believe. 3.7, no, not 3.75, excuse me. It's 2.75. So 2.75 means it's smaller than 3. So our domain is going to be negative infinity to 2.75, 2.75 to 3, 3 to infinity. Again, you can draw yourself a number line to kind of help out. Put negative infinity, infinity, 11/4. We'll pretend that's 11/4, and then a 3, and then we got to jump over these two. That'll help you with the interval notation if it's kind of being a little tricky. Alright, now if we look at g composed with f of x, it's going to be pretty much the same procedure. So I'll let this go without narrating a whole lot about it. Right here, when we're plugging f of x into g of x, notice that we have an x plus 7, so in the denominators we're going to say x can't equal -7. We're going to go ahead and fraction bust. So it's a lot like the previous problem. And distribute, combine like terms, and then I got a denominator again, so I'm going to set the denominator not equal to 0. So what I've done here is I've added 13 to both sides, and then I divided by -2, so that's why it's still negative. -13/2 is 6.5, or -6.5, so that's a little bit less than 7. And then we just got to jump over those bad points. Alright, so if I do draw my number line to kind of help me out here, here would be -7, here would be -13/2. And you can plug this into your calculator and say, hey, this is -6.5 if you want. You don't have to use the fraction if that helps you out. Alright, so this was maybe a little bit longer video than normal, but there's a lot of content.